Okay, guys, so I am going to go over the how to calculate percent composition notes in this video. So, wrong tab. So I'm going to lift up the how to calculate molar mass. So I have this. And yours will be blank, but I've started to fill mine in already, which is okay. So you're going to write the definition of percent composition. And percent composition is the percentage of each element in a compound by mass. And there are a few things we need to remember. So the first thing we need to remember is that the sum of the percentages must equal 100%. The second thing we need to remember is that for a compound, the percent composition will always be the same. So take a moment to write these three things down. Now we're going to get into the formula to calculate percent composition. So we know that percent composition is equal to the element's molar mass over the compound's molar mass times 100, right? You times it by 100 to get it into a percentage, okay? So that's the formula. Let's see if I can focus this. No, it doesn't want to. Okay. So there are steps to calculating percent composition, which I'm going to outline here. So all of this info should fit on the top tab. If it doesn't, that's okay. So steps to calculate percent composition. The first step is to calculate, and I'm going to move that over here. So calculate the mass of each element present. Okay, and that's basically the first step to determining molar mass. The second step, I'm going to go through the steps first, and then I'll walk us through our example. The second step is to calculate the molar mass of the given compound. Calculate the molar mass of the given compound. Okay, once you do that, you're going to divide the mass, step 3, divide the mass of one element by the molar mass of the compound. Okay? Repeat that for all elements. And then step 4 is to multiply your answer by 100. And you're going to repeat that for all of the elements as well. Okay, so my example is potassium bromate. So the formula for potassium bromate is K2CrO4. Okay, so you should know that chromate has a -2 charge, potassium has a +1. That's why there's this 2. Chromate is one of our polyatomic ions. So see, everything builds. So I'm going to walk us through the steps. So step 1, calculate the mass of each element present. And I'm going to label this for you so you know which part is which step. So we have K, C, R, and O. Looking at our formula, we know that we have 2 potassiums. We have 1 chromium and 4 oxygen. Okay, so I'm going to look at my periodic table at potassium. The atomic mass of potassium is 39.1 grams per mole. I'm going to leave my units off so I can save the space on my notes, but just remember, when you're doing this for real, you need your units. The molar mass of chromium is 52.00 grams per mole exactly. 52.00. In oxygen, checking my periodic table, but you'll probably memorize this one first. Oxygen is 16.00 grams per mole. So I have my calculator handy. So 2 times 39.1 is 78.20. 52 times 1 is 52. And then 4 times 16 is 64. Okay, so that's step 1. You're figuring out how many grams of each element are present. Step 2, you're going to add those all together. I'm going to do it right here. It's okay. It shows that it's okay. So we have 194.20 grams per mole. And this is step 2. Okay? So now, step 3. And I'm going to come back up here so I can have space. Divide the mass of one element by the molar mass of the compound. We're going to do this for every single element. So I'm going to set it up the same way. K, C, R, O. So I'm plugging it in now. Okay, so I'm plugging it into this formula. So I'm going to set it up. Save myself some time. Okay. So we're going to do potassium. Potassium's element molar mass is 78.20. And we know that it's grams per mole. The total compound molar mass is 194.20 grams per mole. So I'm going to go through and set all of these up. Notice the number on the bottom stays the same because we're working within the same compound. The number on the top will change with each element. So if this is too fast for you, pause, take a moment, okay? Hopefully you can read this kind of clearly. So that's step 3, plug it in. Step 4 is when we multiply it by 100. Okay, so steps 3 and 4 happen at the same time, unless you want to break up all the math, which will just make a longer process. Okay, so here, let me straighten this out. Oops. Okay, so for our potassium, it is 78.20 divided by 194.20 times 100. And my answer is 40.26. Let me see. My answer on my calculator is 40.2677. I'm going to round that to 40.27. Okay, so we need to be conscious and pay attention to rounding. So 40.27% potassium. Again, when we get our answers, we box them or we circle them. We're going to do the same thing for chromium. So 52 divided by 194.20 times 100. And we're going to get, on my calculator, and there's a glare, but we're going to get 26.776. So I'm going to round that to 26.78% CR. Again, box it. Last but not least, we're going to do the oxygen. So 64 divided by 194.2 times 100 gets us to 32.955. And I will round that to 32.95. Okay? So this is a 5. I'm going to keep that the same. And that is percent oxygen. So that's how you solve the math, but we still need to check our answers, okay? And that's because, remember, the sum of the percentages must equal 100. So I'm going to take these three percentages and I'm going to add them up. Okay, so I have 40.27 plus 26.78 plus 32.95. And that gets me to exactly 100. So I know this is good. So I'm just going to check it off because I know I checked my work. If you get 101, 100.99, 99.99, that's good. That's close enough. But if you're getting like 83, 110, you're probably going to want to redo your work. So with that being said, our percent composition tab of our moldable is done. We have the first tab done and the second tab.